In this video, we're going to see how we can sketch quartic equations. So that's where we have a power 4 involved in our polynomial. So first of all, let's have a little chat about the basic shape of a polynomial graph. So y equals x to the power 4 looks like that. It looks a little bit like a quadratic. The quadratic would look something like this. So it looks a little bit like that, but we can see that it's much bigger over here and over here, because putting numbers to the power 4 is going to make them bigger than putting numbers to the power 2. Unless, one circumstance, unless those numbers are less than 1. If I make very small numbers to the power 4, they're going to be very small numbers. A half times a half times a half times a half is 1 over 16, which is very small, much smaller than just a half times a half. So they look like a quadratic graph, but much steeper for big numbers and much smaller for small numbers. If we had a minus x to the power 4, it looks like that. So in terms of just general directions, they're similar to quadratics. The positive x to the power 4 starts going down, then goes up. The negative x to the power 4 starts going up, then goes down. We'll talk more about directions a little bit later in the video in a shortcut. A little pattern you can spot. If we have more complex quartic equations, we can see here I've got the graph of x to the power 4 plus 2x cubed minus 3x squared minus 5x plus 1. And you can see it's a positive x to the power 4, so it starts going down and ends going up, just the same way as the basic one does. And then we've got these roots in between. If I wanted to know what those roots were, I'd like to factorise this into its 4 different factors, and so we'd have to use a little bit of algebraic division and some factorisation to be able to do that. We can also see we've got some turning points here that for the purpose of this video we're not going to worry too much about, but a little bit later in the year you will be able to work out the exact coordinates of each of these points. This graph here, we've got the graph of minus 2x to the power 4, so this is a negative graph, so it starts going up and ends going down, just like the basic one, where it's negative. And again, in this case, we've got one root there, and we've got a triple repeated root there, and we've got turning points. Right, let's have a look at how to draw these ourselves. Now, most of the time, when you're drawing this, you will be given it in factorised form. You won't have to do a huge amount of factorising, most of the time. So in this case, I can see that I've got x plus 2 is a factor, so that's telling me that minus 2 is a root. The x minus 1 being a factor is telling me that 1 is a root. This is telling me that 5 is a root. And this is telling me that minus 1/2 is a root. So minus 2 is roughly there. Minus 1/2 is roughly there. 1 is roughly there. And 5 will be over here. So those are all the roots. I also want to mark on the intercept on the y-axis. Now I know it intercepts on the y-axis when x is 0. So if I put 0 here, 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 and here, we would just be left with 2 times minus 1 times 5, minus 5 times 1, which would give 10. So I know it's going to intercept at the point 0, 10. The only other thing I need to think about is the direction of this graph. If I were to expand all of this out, I'd have x times x times x times 2x squared, times 2x rather, and all of that would give me 2x to the power 4, so it'd be a positive. So that's telling me it's going to start by going down and end by going up. So using all of that information to draw this graph then, starts going down, goes through -2, goes up through -0.5, goes up to be at 10, goes back through at 1, and then goes through again at 5. And that's my graph. Like I say, don't worry too much about your turning points here. If you drew your turning points a little bit lower, for example, you might have drawn this a bit lower here. That's absolutely fine for now. Like I say, we're not going to work out the exact coordinates of these points yet. We'll do that a little bit later on in the year. So don't worry about how far down you draw those turning points for now. Next. Now in this question, I can see this quadratic hasn't been completely factorised yet. So I'm going to factorise that quickly. I need two numbers that multiply to make -12 and add to make -1. So that's going to be a -4 and a +3. The -4 and the +3 multiply to make -12. And the -4 plus 3 adds to make the -1. Not forgetting I've got the 2 minus x factor and the x factor at the front by itself. Right, looking at this carefully to find the roots then, I've got 0 from the x at the front, 2 from this factor here, 4 from this factor here, and -3 from that factor there. So 0, 2 is roughly there, 4 is roughly over here, and -3 is over here roughly. My y-intercept, well, I kind of already know that's going to be going through 0, 0. But we can check that if you like. The y-intercept will be when x is 0. So if I put 0 here, 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 and here, and you can see that this 0 at the front would multiply all of that by 0. So it doesn't really matter what all of that is. The y-intercept is going to be 0. The other thing to think about is the direction of this graph. If I were to multiply these brackets out, I would have an x times -x times x times x, which would give me a -x to the power 4. So this is going to start going up and end going down. So it's going to look something like this. Going up, go through -3. It doesn't matter how far up you go for your turning point, so coming back down here roughly, going through 0. It's going to go back up through 2. And then my turning point here again, doesn't matter how far up you go for now, and go back down. Next example. We've got roots at -3, -1, and 2, and note that this 2 is a repeated root. So I'm just going to put a little star next to that, because that means it's not going to go through the x-axis at that point. It's going to bounce off and go back. So we've got -3 is roughly here, -1 is there roughly, 2 is over here. I'd like to know the y-intercept. So when x is 0, 0 plus 3 times 0 plus 1 times 0 minus 2, all squared. So 3 times 1 times minus 2 squared. Well, the minus 2 squared is 4 times the 1 times the 3 is 12. In terms of the direction, if I were to expand all these brackets out, x times x times x squared would be a positive x to the power 4. So it's going to start going down and end going up. So it's going to look something like this. Go down, it's going to go through at minus 3. Again, doesn't matter how far down for the turning point. It's going to go back up through minus 1, through at 12. And then, really importantly, this 2 is a repeated root, so we're not going to go through. That would be wrong. Instead, we're going to go down, we're going to touch at 2, and then it's going to go back up. So that's that one. With this one, we've got minus 2 from that first factor, which is roughly over here. Then we've got 1 from this second factor, and notice that this is a triple repeated root. So that means it's going to come down, it's going to touch at 1, and then it's going to keep on going. The y-intercept, let's think about what that would look like. So when x is 0, we've got 2 times minus 1 cubed. Well, the minus 1 cubed is minus 1 times minus 1 times minus 1, which is minus 1. Multiplied by the 2 is minus 2. Now let's think about the direction. If I were to multiply this out, I would have x times x cubed, which would give me a positive x to the power 4. So it's going to start going down, end going up. And it's going to look something like this. It's going to come down, it's going to go through at minus 2. It's then going to have a turning point at some point, so it goes back through up here at 2. And now that 1, remember, is a repeated root 3 times because of that 3. So the graph's going to come up, it's going to touch at 1, and then it's going to keep going. So the triple repeated root looks like this. What about if we had to go the other way? What about if I gave you the graph and you had to work out the equation? So looking at this graph here, I can see I've got a root at minus 2. I can see I've got a repeated root at 1, and then another normal root at 3. So that's making me think, because of the minus 2, that's making me think about the x plus 2 as a factor. Because of the 3 over here, that's making me think that x minus 3 is a factor. And then because of the repeated root at 1, that's making me think about x minus 1 squared because of the repeated root. Now, so far, I've only looked at the factors. There could be a number at the front there that I need to multiply by. Let's check that to see if that would work, because I can see that my y-intercept right now is minus 3. So when x is 0, y is minus 3. So let's check that. Y is minus 3. Now if x was 0, this would be 2. This would be minus 3. This would be minus 1 squared, which is 1. Positive 1. So minus 3 equals a times minus 6 So what that's telling me then is a must be minus 3 divided by minus 6, which is 1/2. Therefore, the equation of this quartic would be y equals 1/2 times x plus 2 times x minus 3 times x minus 1 squared. And if you wanted to, you could expand those brackets, but I'm not going to do that here. The last thing I want to say in this video is just about the recap of all of the different polynomials we've seen so far, and a little pattern you can spot to help you figure out the direction these go in. So when we talk about degree or order, that means like the highest power in the polynomial. So a linear equation has highest power 1 because it's just the simple x, so its degree is 1. Whereas with a quadratic, its highest power is 2, so its degree is 2. A cubic, its highest power is 3, so its degree is 3, and so on. Now, in the left-hand column, I've got if a was positive, so if the number at the front is positive, what would the graph look like? So with a simple y equals ax plus b or mx plus c graph, we know it starts going up like that. With the quadratic, though, we know it starts going down. The cubic starts going up. The quartic starts going down. So notice how it switches. If it's an odd power, it starts going up. If it's an even power, it starts going down. If, however, the number at the front is not positive, if the number at the front is negative, everything I've just said flips. So if it's an odd power, it starts going down. If it's an even power, it starts going up. And that's just a little way you can remember which direction a polynomial will go in based upon its degree, the highest power, and whether the coefficient of that power is positive or negative.